So let's move again to another trip. Agriculture is such important in our region, and not only for our region. The most basic necessity for all of us is food and nourishment. So today the world faces issues on food shortage, and every nation is actively working to ensure food security for his people. So the AI can help also here. There might be some solutions in the form of revolutionary applications in the field of agriculture. So we are going to have a special session only dedicated to agriculture applications of AI. And who best that, again, friends from Mexico. Let me introduce you with Raúl Nanclares da Vega, the Director of Government Intelligence in Jalisco, and Ramon Diaz, the Director of Avances Agronorman, in a chat. They are going to present two cases. One is about agave, the main input for tequila. Everybody wants and loves tequila. And we are going to talk about berries. Everybody loves berries. So we are going to see two examples of how they have been applying AI to improve the activity to gather agave and to gather berries. Please enjoy it.
Hi everyone, we're here in AI for All with Intel, and we are going to start the session on agave and berries, talking about agriculture in Mexico. And I am Raúl Nanclares, and here with me is Ramon from Avances, who's going to present you something about berries, and I'm going to talk about agave, okay, here in Mexico. So just let me share you my screen. So I work for the Jalisco government here in Mexico, and I'm going to show you a project on agave crops detection. Okay, I work for the government innovation coordination, which is an area in the government which does a lot of data science and also a lot of remote sensing. Okay, so this is an outline of the presentation. We're going to go through all this and I hope you enjoy it, okay? So this is an image of a typical agave crop. As you can see, it's planted in rows. So these have some difficulties for our task here, okay? So agave is one of the most emblematic crops in Mexico, as you will know. And Jalisco is the home of the tequila designation of origin. That means that we are, our whole territory is allowed to plant agave tequilana and call it tequila, which is nice, okay? I think everybody knows about tequila. so the tequila production here in Jalisco, as you will imagine, is very important economically and for the development of the state, okay? In 2013, the estimated planting surface was about 89,000 hectares and around 224 million of plants, okay? And also, agriculture here in Jalisco is one of the main drivers of deforestation. So this is a worrying fact, okay? The agave tequila production change must align with society's need to preserve natural resources for future generation. And because of that, since this year, 2021, we started promoting this new certificate, which is called ARA, socially responsible agave, which prices producers and companies which doesn't do deforestation to plant agave, okay? So in this context, it is really vital to monitor the agave crops, okay? And AI, in this case, deep learning is helping us monitor the agave crops and also plants, okay? So this is the logo of the certification you can see here in the right. First bottles are coming out just now. Yeah, so regarding remote sensing of agave, we have some experience with that. I've been working with in this themes in this topic since 2015, 14. Okay, and this is a very difficult task because the characteristics of the crop make it very difficult to detect it with medium resolution sensors as Landsat 8 or Sentinel-2, which are the most common imagery used in remote sensing. Okay, so the signal that the satellites measure, which is the solar radiation reflected by the features in the Earth's surface, is influenced by a lot of things. But in this case, with the agave crops, the soil type has a very big influence. Okay, so that makes it difficult. Okay, so also the different agricultural practices have a very big influence in reflectivity, and the young crops are almost invisible at this scale. So you cannot. You have to guess if it's a agave crop or it's a maize crop or anything else. Okay. And also the low accuracies of remote sensing classification, classical methods doesn't fit the agave tequila pollutant change. They are very, they need very high accuracies because they are measuring a very important product for them, which are agave plants. Okay. Also, UAV and drone imagery is being used frequently in the state to map plant inventory, do phytosanitary surveillance and other tasks, but it's not adequate when you're mapping very large areas. Okay, so we have to bear this in mind. This is an example of the classification I conducted in 2015. Okay, which shows several classes of agave and in different stages of the crop and other classes also. Okay, this the project is conducted by a team of data scientists and remote sensing experts that you can see here. We are part of the Jalisco government, and we work directly with the chief of staff, okay, and work across together with all the secretaries in the state government. This is our team, a small team. And in this case, the AI models are created by the Dr. Ulises Moya and Abraham Sanchez, which are deep learning experts and have a lot of experience with working with, previously with medical imagery, and now we're starting to use satellite imagery. Okay, so this has been a learning process. This is also some of our collaborations. Alejandra Aguilar Ramirez from Semadet, which is the Environment Secretary, Dr. Gabriela Calvario from ITESO, and biologist Ulises Daniel Jimenez Pelayo from UNAM. Okay, and also other institutions in the government, which are Secretary of Agriculture and our coordination. So in Jalisco, we have a pretty big AI ecosystem right now, which is was created with all these actors, universities, companies, research centers. Okay, it's pretty big, right? So what we do to train our model. So this is an introduction to what labels or data is used to train our neural networks. Okay, this is an example of a real label satellite imagery, which is done digitizing by hand. Okay, using GIS software. And okay, the particularities about our model here is that we work with very high resolution imagery, which is not very frequent. And we use imagery from WorldView 2 and WorldView 3 satellites. Okay, and we have only 4 bands in this case, 4 spectral bands, red, green, blue, and near infrared. And we're using 2 different sets of composites. RGB and false color, which uses the infrared band to create curious images, I would say. The spatial resolution or the ground sampling distance is about between 30 and 50 centimeters, which is similar to what you can see in Google Maps or Bing Maps or other online platforms. It's pretty common nowadays. In this case, Agave, the labels are first produced, digitized in my hand, as I said, over the imagery. And this is actually polygons, okay, drawn by hand, which takes a lot of time. And each polygon contains the age of the agave. We have three classes now, which is almost like from 1 to 2 years, 3, 4, and above 5, 6, and 7 years. Okay, that's our main 3 classes right now. And these polygons are then what is called rasterized, right, converted to images, and we obtain a mask. Okay, and this is what we use to train our models. Okay, so this is an overview of the training process. Okay, we tile the image using this grid, and then we extract the image and the mask together, and this is cropped in patches of 256 pixels. Okay, and this is then used to train our models. Okay. Speaking about methods, now we have 2 different architectures that we're exploring: Mask RCNN and UNet++ with a ResNet backbone for those interested in convolutional neural networks. And then we obtain models and do testing. Okay, and this process is repeated in loops to improve the accuracy. Okay. So what results we're getting from our neural networks? Okay, this is an imagery from a drone, not satellite imagery, but right now it's very common to see these images. So this is an example comparing the original image and the mask created by the model. As you can see, it's capable of removing the trees inside the crops and detecting paths and all kind of characteristics. So at this point, it's digitizing better than a human interpreter. Okay, because usually a human interpreter will just draw a polygon of the perimeter of the crop, but in this case, the model is actually removing paths inside the. Okay, so we get a very precise measure of the area of the crop. These are more examples. As you can see, in some cases, the crops are near forests or are behind trees and very difficult conditions. Okay. Some more results. You can see different ages, different in the same image, and as you can see, it's doing the same. It's removing trees, removing paths, removing anything that doesn't have this pattern. Okay, which is what we are doing. We are teaching, or yes, we are teaching the model to understand how the pattern of the crop is. This is some more results. You can see it's doing the same, removing trees from inside the crop. And this is one of the examples because I mentioned deforestation at the start of the talk, and this is one of examples of that. Okay, so in some cases, farmers take or deforest parts of forests and woods to plant their crops. And this is what we're looking for at the end. So what room for improvement we have? So you can see this is a comparison between the ground truth and the results from the neural networks, and some of the small parts of the crop may be missed or wrongly classified. Okay, and we are doing this iterative process of active learning, correcting the results, and and doing all the process repeatedly. So here, this is an example, a very interesting example. We have different crops, ages mixed with forest and other features. The neural network is doing a great job digitizing the agave crops. So what we get from this AI model, what's the benefit? Because we are reducing the labeling time by a factor of 10, comparing to a human interpreted digitizing by hand, which is a lot. And what's the point doing this? Okay, so we have two. Here's a small. I will show you later. What's the point of doing this classification? Understanding how the crops are growing in size, or how much surface is planted with agave crops. Okay, so we can first monitor deforestation, and second, understand the agave tequila production. Okay, so if we get too much crops, then that would make the agave price drop, and that wouldn't be beneficial for anybody. Okay, so here are some figures from our results comparing the two architectures. As you can see, we get an accuracy or mean accurate average precision from the mask sharing model around 0.7 accuracy. In the case of UNET, which measures the accuracy in a different way, we get a 0.9 precision, okay, which is pretty good. Okay, so conclusions. Again, drawing imagery. We have developed a powerful tool to monitor the agave stock using remote sensing images or satellite imagery. And the use of deep learning in this case is in 11 process is helping us reduce the spread validation time by a factor of 10. Okay. The AI and the expert or the human interpreters work together to improve the results and get finer grain labels, so we can improve the scale of the mapping, which is very important for the agave tequila chain production. Okay, the model is not yet finished. We have room for improvement, as I said before. Our goal here is to help make decision makers obtain a better trade-off between production of tequila and sustainability. Okay, and get a better understanding of agave prices and stocks. Okay, and to prevent the excess or lack of agave crops. Okay. So this is all for my part. Thank you, and thanks to Intel for the opportunity to show you our models. And I would like to let Ramon go ahead and start with his presentation. Again, thanks.
Thank you very much, Raul. Hi, everyone. Let me share my screen. Okay, so let's start. Well, I am Ramon Diaz. Thank you very much for your time. Today, we're going to talk about the role of artificial intelligence in cognitive agriculture. I am the co-founder of Norman, which is a high-tech enterprise that has been working for the last years using machine learning and artificial intelligence here in Jalisco. I like to start my presentation by sharing some information that I believe it is very important. I believe it's what I call a dramatic contrast, which is on the first column, according to Singularity University, emerging technologies toward the human being up to 2045 indicate that the human being will increase its longevity. In simple words, we will live longer. Now, on the center part of the screen, here is the current situation in agriculture, where we have climate change, contamination and deterioration of natural resources, and a constant increment in production costs. Now, what is our challenge? We need to increase world food production by 70%. And the question we have to ask is, how are we going to achieve that? With natural or synthetic foods? And the solution to that is what we call cognitive agriculture, which is putting together scientific research, emerging technologies, crop techniques, put them all together to improve the process of the farm. What we think is going to happen is we are facing a change of what has been up to this point an agriculture as an intensive use of agrochemicals. And we are moving toward an agriculture with an intensive use of knowledge. This is, we need to go back and understand how all the natural elements on the ecosystem correlate together in order to improve the processes of the farm. And here is where artificial intelligence takes a primary role. For example, to understand what variables are most likely the ones that have an impact on productivity within the crop, artificial intelligence can be of a lot of help. And let me explain this a little bit further. So what happens is out there on the field, we have several hundreds of variables. The point is we need to understand which are the most important variables that actually have a correlation to the production on the farm. And by machine learning techniques such as principal component analysis, we can actually do a lot of automated variable analysis in pairs to understand which particular variables are actually the ones that are inciding in a particular result on the farm. Now, the first step is to get data. So as you may imagine, what a lot of the farmers are starting to do now is to get measuring stations. But measuring stations are just the first step in order to have a real support system based on artificial intelligence. But of course, the first thing we need to do is get information. So what these measuring stations do is they have sensors and they are sensing all the time variables such as moisture, temperature, electrical conductivity, and so on. So once we have that information, we send it to the cloud, and that is where machine learning and artificial intelligence does the magic. So the huge difference is changing current habits of agriculture. So what was happening before? A farmer would ask for a lab study, and a lab study would mean having a picture of a particular moment of all the physical and chemical elements of the soil. Now that we are reading constantly through sensors, all this information, we can get the whole picture every minute. And that is a huge change in terms of taking the appropriate decisions on the farm. Now, what kind of decisions can be supported to this artificial intelligence system that support the decisions? So let's talk about first regarding irrigation. So we can tell the farmer when to do irrigation based on soil moisture and soil moisture retention capacity. And what has been happening lately is that a farmer that could regularly have irrigation every day now can start having irrigation every 3 or 4 days. Imagine the amount of water that can be saved through this particular innovation. Also, we can talk about fertilization. We can tell the farmer when to do fertilization based on electrical conductivity in order to get a 90% absorption of the fertilization product. And also, we use our state-of-the-art predictive models for early prevention of pests and diseases. And in this particular case, I'd like to go further and explain how are we actually using the predictive models and all the capabilities of artificial intelligence in order to make this happen. So this is the business case of applying artificial intelligence to pest and disease prevention on the crop. So the first thing is to start working on what is called a bioclimatic chamber. This is a chamber that allows you to simulate particular conditions on the crop, such as moisture, temperature, heat units, etc. Now, the key question is to determine what conditions are those that determine the appearance of a plague or disease. And to do that, we need to be very disciplined in terms of having an statistical record of, for each combination of variables, what are we observing on the crop. So we first do this on the lab, and we keep record of this, all these things that are happening on the crop based on the conditions that we are simulating. And that leads us to have a preliminary mathematical model that we need to test further. So as you may imagine, lab conditions are control conditions. And out there on the field, there are a lot of variations regarding those conditions against the control conditions on the lab. So the second step is actually take our records and the patterns we observe on the lab and do the same observations on the field. So it is a process that takes usually about 8 to 12 months. The first 4 months we work on the lab, the last 4 months we work on the field. And the key is to validate under real conditions if the patterns that we observe on the lab are still maintaining in the field. Now, once the conditions have been tested on the field, the algorithm is generated to feed the predictive model. So in our case, we have a linear regression model that helps us to understand the probability of a pest or a disease to appear on the crop at a particular point within the production cycle. And this is very interesting because now the farmer is starting to understand the opportunities behind this. What I mean by that is a customer of us approached and said, okay, so you guys are measuring facts. And based on those facts, you are giving us the probability of a particular pest to appear on the crop. But I also have a weather forecast. And I'd like to know if we actually feed the linear regression model with this weather forecast, if I could be at some point able to understand what are the risks I will be facing if by chance the statistical forecast, weather forecast will actually fulfill. And what we did is we input this other weather forecast information into the mathematical model, the linear regression model, and actually recalculate. And with that, we were able to help the farmer to understand what were the risks he was facing in terms of a probable weather condition on the following 5 to 10 days. And what I'm showing right now is the results of applying this kind of predictive models in the anthracnosis, which is a particular disease in avocado. So what you are seeing on the screen on the bottom of the table is basically three comparison lines. So the one at the bottom is the quantity of avocados that had no treatment, and they serve as a witness in the process of validating and testing the predictive model. In the middle, we have conventional treatment, where the farmer usually uses agrochemical solutions in order to control the disease. And on the top, we have a treatment based on predictive models. And here are the results in terms of healthy foods, measured by kilograms per hectare, where on the witness, the farmer only achieved 400 kilograms per hectare. And on conventional treatment, he was able to achieve 2,500 kilograms per hectare. And on a treatment based on predictive models, which is a preventive model, he was able to achieve 7,500 kilograms per hectare. So here's the huge difference that you can achieve when applying these particular methods. Studies like that, like the one I'm showing above, are also being made at this point for berries. And what we have found is, in this particular study, is that for a temperature at 13 degrees centigrade and 4 hours with 60% of humidity in the leaf, that is the point where the disease, the anthracnosis disease, start to emerge on the crop. And there is a huge AI opportunity on the market. So what I'm showing on the screen right now is, according to a study of the OCDE on 2018, how the farmers in Mexico are split. So as you can see, we have different categories. So we have farmers that are cropping for subsistence. We have some others that are in the transition, which is they are trying to professionalize their services. And we also have another category, which is business starting, and then is business growing, and then is corporate business, which is only 0.3% according to the total. Now, what I'd like to point here is that about 80% of the farmers in Mexico does not have technology in their farms. This is particularly all that is related to the subsistence farmers, the transition farmers, and in business starting, we are starting to find some farmers that are starting to acquire technologies and some other that still don't have any. So there is a huge opportunity because we're facing a convergence of digital transformation and generational change that represents a sweet spot to motivate the use of these technologies. This AI adoption is starting in high-value crops such as berries, avocado, and some others in the area. So this is how big the market is starting to respond to these particular technological opportunities with emerging technologies such as artificial intelligence. And with that, I'd like to end my presentation by inviting you to understand and go deeper into how new technologies such as artificial intelligence and machine learning are able to change in a very dramatic way the way farming is being held right now. So we believe in the following years, there is going to be a very important change in countries like Mexico. Thank you very much for your time. My name is Ramon Diaz, and I am at your service.
Thank you, Raul. Thank you, Ramon.